Okay, Assalamualaikum warahmatullahi wabarakatuh. I am one of the participant in group 4. My group take the experiment free fall. My group have 4 members, which are Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Hakeem bin AZMAN. My matrix number is TB21062. So today I'm gonna present about the theory of the free fall experiment. So historically, in 16th century, the Western European has assumed whenever 10 kilogram object fall to the ground, it will fall faster than the 1 kilogram object. However, Galileo Galilei in 1564 until 1642 has observed have do an experiment. Whenever he dropped two unequal mass from the Leaning Tower of Pisa, so he get that the two objects fall to the ground at the same speed. So we can conclude they have involved a, a constant acceleration within the two objects. So today we know the acceleration is equal to the gravity acceleration. So nowadays the scientists as acceleration is equal 9.81 ms negative 2. Isaac Newton also have explained the free fall motion from the Newton's second law of motion. So from this equation, we can just replace A with the G with also an acceleration, but the gravity is the gravity acceleration. So the formula become F equal to mg. Okay, so we know the third picture and second picture. So the first picture show the how the free fall works. So this also show how the free fall works. Whenever the t is 0, the acceleration becomes 0 also. The initial velocity equal initial velocity. So whenever t is 1 second, it's become 9.8 ms negative 2. There are no negative 2 here because they have some arrow whenever I click this picture. And then the whenever t equal to 2 second, it's become 19.6 ms negative 2. We just multiply with 9.8 ms negative 2. And then okay, from this Isaac Newton equation, we can see that F equal to mg, where m is mass of the object and g is gravity acceleration. And I have do some example and calculation. So for the equation 2, I assume m equal to 5g and g is equal to gravity acceleration 9.81 ms negative 2. So I insert into formula and I get 49.05 Newton. So for equation 4, I assume m is equal to 6g and g is equal to gravity acceleration 9.81 ms negative 2. And then I insert into formula and I get 58.86 Newton. So from the equation and 3 and equation 4, okay, we can prove that the mass of the object is directly proportional to the net force. So this is the F is the net force. So whenever the net force increase, the mass of the object will increase. Or instead, the mass whenever the mass of the object increase, the net force is also increased. Okay, however, in this free fall picture experiment, they they give the value of t and the acceleration. In this formula, we can get the value. They have no they have no room to insert the value of t and acceleration g. Okay, so because the this formula is just want to find the weight of the object towards the gravity. So we know the mass of the object is just like the density of the object. So we know that the mass, the solid, liquid and gas have their own density. So whenever the solid have their density is equal to the mass of the object. So we just multiply it to find the weight of the object towards the gravity. So if we want to find the value of heat on each second and each acceleration, we just need to use this formula where h equal to 1 per 2 gt power of 2, where g is gravity acceleration 9.81 m negative 2. And I have do some example here. So for equation 5, I assume t is equal to 3 and gravity acceleration g is equal to, as we know, 9.81 m negative 2. And then I say the formula and I get 44.145 centimeter. So for question 6, I assume t equal to 4, where 3 plus 1 and 3 plus 1 equal to 4, and I just add 1 here. So it is equal to 4, and gravity acceleration as we know 9.81 m negative 2. I add into this formula and I get 78.48 centimeter. So for equation 5 and equation 6, we can prove that the falling distance h is directly proportional with square of the falling time. So we can conclude that whenever the falling distance increase, the square of falling time also increase. So instead, whenever the square of falling time increase, the falling distance also increase. However, uh, in these experiments, from the table in the experiment, we got we got the value of h, and the value of we can the value of t. We cannot find we the value of g is not given. So from this equation, is given that 9.81 m negative 2. However, in this formula, however in the experiments, we we have to find the gravity acceleration on our own. So I assume, okay, so we use this formula, which g equal to 2h per t power of 2. And then I assume h equal to 78.48 centimeter. So the value of h, I just uh, get from here, from previous calculation here, because I would just want to show some example. So I insert this formula, and then I use 4 also, just like here, and then I get again the value of gravity acceleration, which is equal 9.81 m negative 2. So from this for the experiment, we can use this formula to find the gravity acceleration. Where h can be any value, just like 475, and t is equal to what we have observed, and insert into the table in the experiment, and then we just insert into the formula, and we get the value of gravity acceleration. So that's all. Thank you.
Assalamualaikum. For my part, I will explain the apparatus used for the experiment, and then I will explain step by step about the procedure and explain how the data taken during the experiment. For the apparatus that used in this experiment, we use masking tape as the measuring meter, and then measuring tape, marble, and application in the phone, which is acoustic stopwatch as our stopwatch. First step to prepare the experiment, First, we need to use the measuring tape to measure from the 0 until 100 cm, which is followed by in our lab. And then pin the with marker or pencil one by one 10 cm until 100 cm, and then place the masking tape one by one, and then mark with the marker 10 cm until 100 cm. For this part, I will explain you how this experiment works and how the data taken. For free fall experiment, we need the purpose of the free fall experiment is to find the time from the different height to initial position. The time taken will be used smartphone stopwatch. For first height, I will use 100 cm. The time I will be showing you later. And then repeat with the same marble with the different height. And then repeat with the same marble with the different height, which is 80, 70 until 10 cm. The data will be shown after this.
Okay, next for observation, we made 10 different height of 20, 40, 60 and up to 100 cm with a constant weight of marble which is 5 gram. The result we get is that the higher the height of the level of the release, the marble, the higher the time taken we get. This affects the gravitational acceleration of the Earth is constant. The distance and item fall is proportional to the time span falling. Okay, for the graph part, we found that the relationship between displacement and time is directly proportional, as you can see the graph in this video. Okay, thank you.
I want to present about safety and precaution for this experiment. Firstly, to measure a height, students have to make sure that the eyes position is correct, because if the eyes is not directly across from what is being measured, the measuring scale will give an inaccurate reading. Secondly, for accurate results, the stopwatch must start parallel to the marble release. Last but not least, the marble must release with the same force for each height. Thank you.